This video is going to cover the topic of perimeter and area of triangles. Be sure the date and topic are at the top of your page. The essential question that will guide this video is what measurements do we need to find the perimeter and area of a triangle? Today we explored finding the area and perimeter of triangles, so I'm just going to take a quick minute to recap some of the important information. We'll start with perimeter. Of course, perimeter is the distance around a shape. So just like we did when we found the perimeter of a rectangle, we need to total the lengths of each side. For triangles, that looks like perimeter equals side plus side plus side. So if we had this triangle, we could find the perimeter by adding all the sides. Straightforward enough, right? Something that carries on from what we've done with other shapes, just adding up the sides. We've worked a bit with finding areas of triangles as well, and we saw in class there's a connection with triangles and rectangles. If I have this triangle and I draw the rectangle around it, I can see the area, or the space it takes, is half of the rectangle, right? It's 1/2 of the rectangle. Since we find the area of a rectangle by multiplying the base times the height, I can do that for the triangle, but then cut it in half or divide it by 2 to figure out how much is just the triangle's area. So for example, in this case, I would do 4 times 3, which is 12, and then divide that by 2, which means the area is 6 square units. You will see this written commonly 2 different ways, and it's important that you know both of these ways that you might see this. You might see it as I've written it before. Area is the base times the height divided by 2. But you also might see it as the area is 1/2 times the base times the height. Both of these are going to be just as easy to use, right? You can just decide which one works best for you. They'll both get you the same result in the end. Something that's very important to know, however, is that the base and the height are sometimes hidden in a triangle. Sometimes the height is inside a triangle. Wherever the base and height are, what's important is that they must meet at a right angle. That means that when they meet, they must meet in this L shape, right? This is our right angle. It's 90 degrees, so they have to meet in a corner like that. So sometimes we have to search for a minute to find it, but once we've found the base and the height, we can use the same strategy or formula to calculate the area. I'll show you an example. Here I have a triangle, and the sides are all labeled, which would make it really easy if I was looking for the perimeter. However, here I want to find the area, and I don't see any lines where the triangle is meeting at a right angle. But it looks like my 8 is my base, right? That's what it's sitting on. So if I'm looking for the right angle, I kind of imagine walking up to the top of the triangle at the very tip top and dropping a string straight down. Gravity will bring it straight down, and there, all of a sudden, I have a right angle. This is actually the height of my triangle, which means the height of my triangle, if I count these spaces, is 5 units. Now that I have my base of 8 and my height of 5, I can go ahead and do my normal calculation for area, right? So 8 times 5 would be 40, but then I have to divide that by 2, so the area here is 20 units squared. These extra numbers here, while they would be useful if I was finding perimeter, actually have nothing to do with finding the area because they are neither the base nor the height. Here's another funny example. Right? I have a triangle, I have all my sides labeled, but again, if I want to find the area, I need the base and the height, and they have to meet at a right angle. I don't see any of these lines meeting at a right angle like that, but I do see that 2 appears to be my base. It's what it's sitting on. So if I went up to the top of this triangle, right up here, and dropped a piece of string, maybe with a penny on it, it would make a line like this. That's my height. So my height is actually 1, 2, 3, 4, 5 units. I now know that my base is 2 and my height is 5, so I can proceed with finding my area. I would first need to multiply my 2 by 5. I would then know that it's a triangle, so I have to cut it in half, divide it by 2, and I would find that my area is 5 square units, or 5 units squared. Again, this 6 and this 8, while useful for finding perimeter, has nothing to do with finding the area because they are neither of those are the height, nor are they the base. Remember, the essential question for this video was what measurements do we need to calculate the perimeter and the area of a triangle? And we saw for a perimeter, we need all 3 of the sides. To find the area, however, we need to know the base and the height of the triangle. And we need to recognize that the base and the height of a triangle are always the 2 lines, wherever they are, that meet in a right angle in a corner. For your turn, take a look at the image that I have here for you and determine which of the values you need to calculate the perimeter and the area. And then you'll go ahead and calculate each of those. And we'll of course be practicing more of this in class together.